My name is Daniel and I try to build my own SQL database just to learn more about SQL. Unconventionally, I use the programming language of Java to do so because I'm just a better Java programmer than I am a C programmer. Furthermore, I want to use as few dependencies as possible and try to write everything by myself. So join me in my journey and subscribe to this channel. In this video, we are saving a table to the disk, but before that, I made some improvements to some other classes. First of all, you remember when we did all the data types and we defined a data type as an enum, and each data type has this interface. I made this interface generic. So getValue returns now some kind of generic object. A byte array is actually transformed to a data type. Then I looked at the different data types, and what was really stupid to do was I used to return a string instead of the data type, which was, just stupid. I fixed that in each data type, not just the numerics, but also on the date, the texts, and so on. I added two more methods to each data type. One is toByteArray, which actually transforms or parses the data type. In this case, it's big int, which is internally a long. And the reverse thing, we have from byte array, you give it a byte array and it returns a long, and here it returns a byte array. These are now in all data types, except in one, which is text, because I don't know yet how to save text in a very good way. Well, actually, I do have an idea, but I haven't implemented it yet. In the table package, I created a class. It's called Saver. And this class, well, it needs some refactoring. It's not perfect yet. This class actually saves a table. So first of all, we have a logger here, and then we have the constructor. The constructor needs the directory where it's going to be saved. Then it needs the tree, which is actually the table. Each table has a UUID, which is used as the name of the file. We have the name of the database and the version of the file format. Now let's have a look at the file format. You can scroll down here and you find the data type description text. That's the wrong one. This one here. So this is actually the way the file is saved. First, we have a file identifier. Most file types do have an 4-bit identifier. In our case, it's just this. I just took this one. It's a random number, but the software can evaluate your operating system can evaluate by this file identifier what file type it is without looking at the ending, which is normally used in Windows systems, but other systems just depend on this file identifier. Then we have the header, and then we have the data. Now let's look at the header. The header is, here you can see it in table 2. First of all, we have the version of the file type. Why do we need the version of a file type? It's simple, because we might later on have better ways to save a file. We don't know it yet, but our software needs to be able to handle all those different file progressions, and so it has a version, which is a float. Right now it's just 0.1. Then we save as a short, we save the number of columns. Then we have this part, the part of, and next file. So what's the thing about that? Some operating systems do not allow files bigger than 4 gigabytes, which is quite a big file, but for a database, it can be a little bit, it can be just like not enough. So we have to split the file on the disk. And here it says it's part 1 of 4 parts. And the next file is saved in next file. When you're there on part 4 of 4, you know you read the whole table, which is then 16 gigabytes big. So these are those 3 parts. Then we have the table name, which is a varchar. The column names, like it's an array of varchars. And the column definitions, which also is an array of varchars. Varchar is, we're gonna implement it to be variable character array. So what we are doing is we save not only the character array, but also the length of the character array. You can see it in this little table here. So each varchar is the length and then the character array. So we know when this character array ends, after how many bytes this character array ends, and the next field starts, or the next field starts. So that's how we are storing varchars. And if you have an array of varchars, it's just like a short character array, then again a short character array, then again a number short, which is short, and a character array. Let's close this here. So if you want to see more or read more upon the whole thing, you can actually look at this file. I actually described it all there in words, and that's about it. So let's save the file. So first of all, we create a file name, which is the UUID, and it has the ending moi. Then we create the path of the file. So we take the directory, a file separator, and a file name, and we create a file output stream on this path. Good. Then we create this magic number on the beginning of each file, which can be interpreted as loco. Yeah, a little bit crazy. We're all a little bit crazy, and that's the first thing we write onto the file. Then we do the version again, and since we save it as a decimal, like our own data type, we can use the 2-byte array and do not have to transform it in here. So we write the version number. Then we write the number of columns. So we look at the tree, we get the data structure. The data structure is the definition of each column, and it's an array. And if we want to have it, want to know how many columns we have, we just take the length of this data structure and we convert it to short. This here limits our number of columns to 32,000. I think 32,000 columns per table is plenty enough. So we create this short, we transformed it to a byte buffer, and then we write this short onto the file. Then we have the parts. Remember part 1 of 4 because its files should not be bigger than 4 gigabytes. Right now it's not implemented yet. It's always 1. So it's always part 1 of 1. So we write a 1 in S byte, and the next we write another one in bytes. We do the same thing for the name of the next file, which has to be in the same directory as the previous file. And this is a varchar, and that's the first time we write first the length of the varchar and then the name of the file. We do the same thing with the table name. And then we go through the column names. Then we save all the column names. Again, we look how many column names we have in the table, and we iterate through them. And for each column, we write again the short, and then for the length of the varchar, and then we write the varchar. We do the same thing with the data types. However, we need to get the data, we have to parse this enum here to a string, and that's again used as a varchar, and then we trim it so it's shortened. We should change varchar not to use always 255 characters, but that's another thing. We're gonna do that in a future episode. Then we look how long it is, and then we write the length of the type definition, and we write the type definition. So now we write the data. Writing the data is not that hard. First we get the first leaf, which is, if you remember the trees, the leaf which is furthest to the left, and then each leaf has a pointer to the next leaf. So we continue going to the next leaf until there is no next leaf. So this means give me the next leaf until there is no more next leaf. Each leaf we are right now, which is the current leaf, I get all the rows, which is here. Then we go through all the rows that are in the leaf. We go then for each row has a cell, and then we write the cell to a byte array, because the cell is of type iDataType, and iDataType has this 2-byte array, so we can use this and just write it to the disk. We cannot do it if it's a varchar, because we need the length of the varchar before we save it, and therefore we have to check if it's varchar, and then we write the length and the char array. We do that with every leaf, and if we finished with this leaf, we're gonna take the next leaf until the next leaf is null, and then the whole thing stops. We close our what is it? Output stream. Where is it? Our file output stream. We close it. I wrote a little saver test, which actually is not testing anything. It's just saving something. Yeah. So let's run it. So we saved our table, which we created in the space test. If you remember it, it is those 1,000 most populated countries we have there as a CSV file. We imported it like last week or 2 weeks ago. We used this small list to save it on the disk. So let's have a look at the file. I just opened it here. You can see it. That's when we created it. That's today. And that's the UUID, and it's 37 kilobytes big, which is not that big, which is, rather nice. But we also want to read it, and therefore I created a disk importer, which is this class. Again, it has a logger, and it has some private fields on top. A constructor takes the directory in the UUID, and it has a load table, and it returns a table. In the beginning, the table is null. Again, we can generate the path to this file, and we use random access file as an input stream. So try catch block. We are not writing anything, so we are in read mode. And here we go. So first we read the first 4 bytes. This input this method works a little bit strange. I had to look it up because it was not very intuitive. This here is the byte array you want to copy into. That's the starting position of this byte array where you want to copy it into, and then you say how many bytes you want to read from this random access file. And then those 4 bytes are placed in this byte array. If we use this here, we have the first bytes in here. Then we have version, which is the next bytes, which is a float. There are, if you do basic data types, this random access file provides a read float and read int and double and so on, which is actually quite nice. So the version is the next, which is a float. I don't know how many bytes a float is. I think it's 32. Then we read the number of columns, which is a short. Then the part is also a short. Part of is a short. Here we read actually the character array, again with this in-punct read method, where this is the target where we start, and it's that length. And we create a string, and next file is a string. Now we have 3 methods, which is extract table name, extract column names, and column definitions. Let's go to extract table name. It's quite simple. It just reads varchar array. No, it reads a varchar, which is the length, the bytes. Again, with this, we copy it to this byte array. String provides a method where you actually give it a byte array, and it creates a string, which then is the table name. Next one is the next one in the here we're gonna go is the extract column names. Let's check them out too. For each column, we know the number of columns. We iterate it in this for loop, and then we read the short and the character array and add it to this list. And we do the same thing with the column definitions. Again, for each column, we go through all that, and we read the varchar, which we internally use a string for it, and we trim it. If it's not empty, we just add the enum type, which we can get from the value of method. Now let's go back again. Now we can create a table. This is the table we created, and we don't know how many rows are in this file, so I use the list. There's another method called read data, which takes the table, the random access file, this array list, and we read it. This method is a little bit longer. We read now the whole file till the end. The problem with the random access file in is that it does not have end of file something where you can actually, like, if it's null or if the next thing is null. I didn't find anything. I googled it, and the best thing I could find is it throws an end of file exception. So we actually are in a while loop until an end of file exception is thrown, which is, I know it sounds strange, but I didn't find any better way to do it. If you have an idea how to make it better, please go ahead. First, I create a new temporary row, and then we iterate through the whole row and check what kind of data type it is. If the first cell in the row is of type big int, which it has to be because it's an ID, we add a new big int, which has actually those, what is it? It's 64 bits. That's 8 bytes. So it reads those 8 bytes, transforms them into a big int, and adds it to this row. If the next one is a decimal, we do the same with the decimal. If the next one is a float, or if the next one is another decimal. So we do it for every cell. We parse it into the right data type and then add it to this temporary row. So we go through this whole thing. And if it's a varchar, we have to do this whole varchar thing with the length of the character array and then the character array, and then we use varchar and we use new string. So we parse it several times, but that's about it. In the end, we go through this temporary row and transform it to an actually idata type row. Here, that's just for us. It's just a printout for us to observe. But what we could actually do is, in the end of the row, it has the line break, and we add this row to all the rows, and that's about it. So let's test it. If it works, hit run. Wow. Okay. Wow, that looks pretty good. Our first city is Tokyo. That's the coordinates. It's in Japan and has 37 million people living there. And now we have the data file version is 0.1, which is good. We have number of columns 6. We have part 1 of 1. Next file is empty. Table name is cities. Column names, that's correct. And column types, that's correct as well. Wow. So now we're able to save table to the disk and read it from disk. Thank you very much for watching this video. Like always, you find the source code on GitHub. I hope you had a great time. Have a very nice week and see you next Sunday.